I'm Grigore, founder and CEO of PySquared. And what we do at PySquared is to build the next generation of and the fastest decentralized network for payments, for humans and AI. All the talks so far were about AI, and AI is great, will be greater. But in the end, all the agents will need to use a payment system. And blockchains are not ready for that. And that's why we work on what we work in PySquared. The web was built for humans. Humans fill forms. They keep track of accounts. They type in credit card numbers. And the internet doesn't have a payment layer yet. It was meant to have, but it doesn't yet. On the other hand, AI agents, they are not patient. They do not fill forms. They do not type in credit card numbers. They just want to move fast. Well, in 1996, there was a standard introduced in the internet, the HTTP 402, for payments, payment required. So the builders of the internet envisioned the fact that there will be a moment where we need to do payments on the internet. But crypto was not there. And we were not ready for it. It was way ahead of its time. But the time has come to do it. And as we know, Coinbase introduced X402 recently to address this problem in the internet. And then very soon after, BitGPT introduced AGI402. And essentially, they work as follows. So a client wants to use a certain service, they make a request, and then the server says, hey, 402, payment required. All right, then the client submits the payment, and then the server gets to a blockchain or some Web3 infrastructure where the actual payment happens. And then with a proof of that payment, you go back to the server gets back to the client together with the service that was paid for. So that's the main idea. There are details, X402 versus H402, but this is the important thing. Well, the problem is that last part. Specifically, imagine that there will be hundreds of thousands, millions of agents, humans, at the same time, wanting to do payments, wanting to use this 402 feature. Currently, we use blockchains because many of us identify crypto, Web3 with blockchains. How else? The problem is that blockchains enforce this huge bottleneck. Imagine all these transactions, all these intents, payment intents, come to the blockchain and they are bottlenecked because they have to be now sequenced and treated in order, which is ridiculous if we think about it. Because many payments are completely independent. Agents, your agent, my agent, they work independently. Why should they stay in line after each other? We just take it for granted because we say, how else? Because we have ledgers, and ledgers are what they are, so it must be like that. No, it doesn't. Oh, sorry. It doesn't have to be like that. And that's what we do at PySquared. We proposed a protocol called FastSet, which is inspired from research that is relatively new, recent, in the last 5-6 years. There is a series of protocols and ideas that were proposed that show, mathematically, rigorously, that you can avoid double spending without totally ordering the transactions. So in early 2000, Nakamoto and many others believed that that's the only way to avoid double spending. They just totally order all the transactions and now you cannot have double spending. No, there is another way. But not many people know it. How many people here know the FastPay protocol or heard of the FastPay protocol? Not from our team. Not from our team. Nobody, you see? And the answer is there already scientifically. So what we did, we took that and generalized the protocol, and now it works with any programming languages, any computations of any kind. And what it gives you is, one, speed. Imagine that you can do everything you do on a blockchain, all the payments, verifiability, security, everything, but at unlimited TPS. Not 100,000 TPS, not a million TPS, but unlimited. If you need more TPS, add more validators to the network. Let's put it this way. So you can do it at the speed of the internet. It's all massively parallel. There is no sequencing, no blocks either. May sound weird, but it's all rigorously proved. Please go and read our white paper and you'll see. And it's also ridiculously cheap. It just costs the computation itself, which is very fast. Think fractions of a cent. So that's what fastset protocol gives you, and it is particularly suitable for AI agents. And it's not only that it is fast, but the real question is, what does this enable in the future? So we'll see lots of applications where you can pay, for example, per article. If I want to go to New Yorker, I only care about one article. I don't want to subscribe for a whole year. I just want to one article. Or you can imagine cloud micropayments. Your fridge will ask the utility company what's the price of electricity, and then it will start or not your freezer, or it will start when it's cheaper, and so on and so forth. You pay for what you need. It's particularly AI agents. They need only pieces of information. You don't want to pay a $500 annual SaaS subscription when you only need something very quickly and very cheap. And with that, I'd like to run a video, if possible. All right, here is a video which shows FastPay integrated with the H402 protocol to see how seamless it is, how easy it is. This is in a browser. Come on. Can you help me? Tech, tech guys, please, can you run this video for me? All right, so this is a very simple web interface where you pay an agent to do something for you, to generate an image. It doesn't really matter what it does, but the point is that it runs the entire 402 protocol. And you'll see how seamless the payment is and how instantaneous. All right. In the meanwhile, I can tell you that our current implementation of Fastset reached 250,000 TPS with less than 100 millisecond latency. And all the payments are completely independent. If I make a payment, you make a payment, you don't have to wait for me, I don't have to wait for you. They are completely finalized in parallel, independent of each other. Can we start the video? Maybe. Right, so I can tell you what happens here. So you type cake, let's say in the image prompt, and you ask the AI to generate, the model to generate a cake image for you. But of course you have to pay for it. So it will send you a message, please pay, then you pay, and then you'll see how quickly the payment happens, and then the image will be generated for you. So the service will be done for you. And I think that's it. We don't have time, right, for it anymore. Because in the, yeah, whatever. Let's not worry about it. So that's it. Maybe ask questions instead. Thank you. Lunch.
Hi.
Yes.
Yeah, here. So you talked about how blockchains are slow and are not great for settlement of payments, micropayments. So that is true for chains like Ethereum, where there is sequential transactions. But there are now chains which support parallel execution as well. So Sui is one of the ones that comes on top of my head. Yes. So how would PySquare compare to those chains?
So those blockchains, very good question. So those blockchains like Sui, for example, they use parallelism as an optimization. They say, we guarantee a sequential model, deterministic sequential model, but as an optimization, there are certain transactions that we know they can be done in parallel, like single object updates and so on. And we are going to do those in parallel to move a bit faster for it. It's an optimization overall. We take a different stance. We say parallelism first. Everything must be parallel. If you need sequentiality, then you program it. So you can write a sequential protocol, like a trading platform, for example, or Uniswap-like protocol. That would be a smart contract on Fastset that you have to program. You have to program sequentiality on top of an otherwise massively, embarrassingly parallel platform, right? So forget sequentiality altogether. It's parallelism first. And by the way, in case you don't know, more than 90%, 93% specifically, have all the transactions on Ethereum do not need a total order. Payments, any digital asset transfers, meme coins, none of those require a total order. Yet everybody pays the price. And nobody has the courage to raise the point. So maybe we should drop completely the idea of sequentiality. And if you need sequentiality in those 7% of cases, program it. Concurrency 101 I'm wearing my professor hat. This is my professor hat. Right, so we know how to program sequential lists on top of otherwise massively concurrent replica-based distributed systems. All right, thank you.